Okay, it looks like we're streaming, but I'm just waiting for the image to come through on the YouTube dashboard. Because, you want it to come through. Cool. Right, it is Monday evening. So, what time is it? About 8:30, so about an hour earlier than usual. Quite a long break. We haven't streamed since Wednesday. And this is episode 7 of Writing a Little Interpreter. Trip away at the weekend, so there was no streaming. Went to visit some family, and obviously Thursday was Valentine's, so that was a no streaming night as well. Unsure this week what the schedule's going to be like, but we've got a bit of easy goings in terms of code for the next hour or two. Last time we left off, we had ClangTidy C-Line had graciously messed up some of our formatting for us, to which we are forever grateful. Well, got a lot to fix there. But other than the C-Line formatting, we'd reached a point where we had an AST tree coming out of the parser. Sure, there's plenty of bugs, and that is currently not a concern. What I'm trying to do is, let's delete that, because we no longer what we're trying to do is get something up and running. Then we can iterate on it, we can improve the performance characteristics of it, and we can, control effect, yeah. And we can add better error checking, better error messages, and so on, and start to refine it into something that's more reasonable. For instance, our string in turning, when we look up something, is quite literally a vector, a static vector at that, so not thread safe and all that. But what importantly we have, for instance, is a very simple interface, so we can iterate on that, make it thread safe, make the lookup faster rather than the search through when we're looking up a string to get an ID, and so on. The same with Alexa. It's probably not perfect. We've still got some more things to add to it, I imagine, but it's definitely not perfect. Look, we've got some. Let's not drag that anywhere. Where are you? We've got these guys, which we were thinking of getting rid of to remove the user child list. Not planning on doing a run through the to-dos today, but let's see how many there are. There it is. We have 16 to-dos in our project, of which there are not that many lines of code, so to do this off screen, work out how many lines of code we've got. Goodness, but they really should do clog source. Only 5 unique files, so we've only got 800 lines of code, and that's pretty good. So we have, with very minimal library support, we use the std vector, bit of standard moving, and that's it. We've got a lexer and a parser, which is parsing the parser tree reasonably well in 850 lines of code. Extending that now shouldn't be too difficult. The lexer is going to extend fairly easily, even if it's not optimal. And the parser should now extend. We're putting the bulk of the levels of precedence, so as we have more things, it should be pretty easy to do. We haven't done a run on the bugs yet. We haven't done any testing. I'm trying to delay that for as long as possible, but overall we shall. Things are looking pretty good. Line count's going to go up a bit today because we're going to split up the parser out of our main file and put it into its own file, obviously called parser.cpp, and let's start that. So what we want to do is make a that is no longer used. One of the nice things about so we had that originally, but then we added the talk yourself through it for hopefully you can see that. Yep. Originally something that let us step back. We were stepping forward, checking the token, and stepping back. Turns out that's no longer used because we added a peep function. Peep or peek. Peek always reminds me of reading a memory address in BASIC, so maybe peep could do look ahead, but I like the word peep or peek. Peekaboo, peep, peek. Does it matter? Let's see whether there's a peek. To peek, to have a peep, have a peek. To take a secret, spy on. You know what? I like the word peek because it reminds me of programming in BASIC, or the old Amiga Amos thing, where you would read a memory address by using peek, and if you wanted to set a memory address, you would use poke. Of course, I didn't think of it like that. I was thinking about memory banks back then because I didn't really know what a memory or a pointer was, but it was abstracted away from me, should we say. Awesome. A bit of refactoring. Right. So, without further ado, I don't think there's much else to discuss. I'm going to keep pushing on, seeing how far we get within the month. I started this on about the 1st of February, maybe the 2nd or 3rd. What I wanted to do is see how much I could get done in February. I knew there was going to be some blocks of days off, so, and yeah, and we're just over halfway now, aren't we? What are we at? Oh, we're actually, where are we? 18, so we've got 10 more days. We'll see how far we get. It'd be nice to progress a little bit more, and then we shall review and plan for March. Right. First up, new C++ class. Parser. And here we go. Created by Paul. Awesome. I'm sure I can alter the template file on these, but the amount of new files we create, I can't be bothered to even look it up. Okay, that was in there. I'm not interested in who created it, are we? This has to remain public, obviously. So let's put that into here, because we're going to need to walk the trees, so we're going to need to know about that. And it looks like we need to include the AST cstudint. Awesome. Maybe use a short. One of the things I'd also like to do, I know it's a bit of a fashionable thing at the moment, is make sure the compile times stay reasonably short. I mean, we're not super fast at the moment, in part because, sorry, excuse me while I look at my phone, in part because we're not using Ninja. CMake, CLAN doesn't support Ninja, and that's something I'm hoping they will soon support, because that, my experience with the Ninja, using CMake to generate a Ninja file is things get a lot more performant. I'm not doing any pre-compiled headers either. Honestly, I never set them up at home. And should we have a look at how long it takes to rebuild? Rebuild all in debug. 720. But that did not build a tokenizer. Must have built it, 'cause it wouldn't run otherwise. Yes. I've got a Generation 1 AMD Ryzen 1600 or 1600X, I can't remember. And I did not make myself a cup of tea. I've got some cold water, so we shall see how well I rebuild project. It is 700 milliseconds, so, which you wouldn't expect it to take very long. But we're not lighting up all 6 cores, because there's only 4 files. But hey, right. Where were we? We were about to look at main. While we do this refactoring, I'd like to one less to do. We don't use you. Now all these have to stay while we're public, not stay, obviously. Staying, they're going. Hello nodes. Kind of string. At some point I think we will probably put a lot of these in base types, but let's put that in parser for now. Front-end types or something like that for now. It's added to doing, we delete ones. Let's do consider putting all these in. Why they are created by the parser, we're going to use them a lot where we don't necessarily want to put it in the parser. Oh, look at that, none of them are used, but I don't think it's talking properly at the moment. Main is done. Token to kind is static. Type. Well, we're going to be dealing with you a lot, so you've definitely got to stay public. Oh look, string ID, so it is include. Actually, that actually did what I think it did, yeah. So, see if it builds. Oh dear. Because we don't have I'm trying to get out of the habit of doing that. I want to start making use of some of the cool refactoring tools. Makes me feel like I'm using Java again. Just keep on including everything. Main type is done. Node and that. Can go here. Now this is a sad moment. We've got to include vector. I don't like putting vector in a header file because say goodbye to build times. Okay, node builder. That is a secret. As is ClassLexer. As is the parser. Now we'll get to that in a minute once we scroll past hundreds of lines. That is the parser. Right, now, look here, what we want is something that turns an AST. It's called parse code. 4 days off, I'm not thinking about the you want that. What I don't want to do is put the whole class in there. There's no point. It's a function operation. You've got some code, you send it in, you get an abstract syntax tree back or some error messaging. I haven't quite decided what we're going to do with error messaging. At the moment we just abort, which is fine. We might do a logger or better logging system and go from there. But importantly, there's no point having a class exposed in the interface. It stops us from change things, or when we change things, it will see a header file, which increases our build times when we're iterating. We just want a function that says parse code, give me the AST back, plus an error message maybe. Now that can do its magic down here, or total lack of magic. We create a parser object. Again, I haven't quite got the tokens. So what are we going to do? We're going to tokenize the full thing. Tokenize code. Tokens. Here we go. Awesome. This makes us so we've totally cleaned up main now, apart from my comments. We don't need you there, we don't need you or you, and we don't actually need you. I've deleted my comments, I've got a very minimal main, looking at it, there's some code which will one day be load file, but for now won't be. Path the code, got the ST, and we're good to go. Next is we'll do something like that. We don't have a type check yet, but that will be our next job. And there we have it. But for now, we've got this. And it works still. Review what we've done. We're removing files. We're putting the bare minimum we can in the header file. Unfortunately, it's quite a lot. There. I'm half tempted to remove these. No, because I kind of like refactoring when I'm just chilling out. To-do, moves, lots of to-dos. May not need this, we definitely need that at the moment anyway. Makes things very clear. We're good to go. Okay, I've got loads of to-dos. Oh, 9 warnings for my code analysis and that. Could fix them. We will fix them before we ever release this code. It will be fixed, but not today. Wait, that's effectively what it's done. It's shifted the parser out, so I don't need to think about it anymore. I fixed bugs, so I hid them, but I'm not going to think about you anymore, parser. Review what we've got to do. Improve error messages. They are rubbish. We should do that. Maybe error recovery. Again, that's more parser work. Type check, which means we've got to create a symbol table, which is going to be cool because we're probably going to use a vector. It's going to be great because when you use the vector, you get to, sometimes it comes out fast, sometimes you get to optimize it. Add comments. We could do that. Does the tokenizer work? Not for now. We're not. That'll be more important when we actually come to write code. I'd rather do things that are important. So at the moment, we don't have anything working. What's the point of improving error messages if we've not got anything working? It helps me debug a little bit, but once we're loading a file up, that becomes much more important. Same with comments. What's the point of me writing a comment? I'm writing single line bits of code, which is just tests. So that. Do a run on the to-dos. To-do comments. Yes. Fix up delivery slow code. Well, I'm saving that for when it's fun and some testing. And I've got a collection of stuff. So, next problem is type checking. Where should we talk about that? Here. Type check. I didn't keep that there, did I? Oh. What are we going to do here? Type check. So we have to work out whether this is well formed in the sense that give it a name. 100. 10. That should work. If we try and send the wrong type, it should error. I mean, that's logical. So the things we need to be able to do is we need to be able to look up foo and get back its type signature. So look up foo, find foo has type I32, I64, and a return type of all. When we know that return type, we just walk along the parameters and go, what type are you? If we don't know what type you are, for instance, you could be a bar function, we have to look up the return type of that. If we don't know the return type of that, we have to go and infer it. Okay, now where do we store these things? How do we look them up? Well, every single scope has a symbol table. So there's a global scope, a dictionary. A symbol table of the possible words for a dictionary. We look up the name and we get back information. In this case, we're only going to get back the type information because there's not much else to do. So we need to create the symbol tables. Every time we hit a code block or module, as my outer one is called, we create a new symbol table. So we create a symbol table here, but in theory, if we had a if z less than 100, let z1 equals z times 2. Z1. We're questioning a symbol table here, in which case the let would be put into that symbol table, so we couldn't use Z1 outside of this statement. Pretty much it. So every symbol knows its parent. So if we use Z there, it will go boom, go up and find it in this scope here. And if we use bar, which we haven't defined, but if it's a function, then it would probably all out to the global scope and go, hey, there's a bar function. Yes, no typing errors, everything's explicit. So that pretty much sums it up. So types can be functions or can look up from functions or variables. Currently only built-in ones. So what I'm wondering is whether it's worth having a similar thing to intern string called intern type, which gives us a single identifier for it, and then we can look it up. I'm not sure it's worth it at the moment. We've only got built-in types. If we had a struct, then I would just say have a pointer to it. Yes, I would say that. So in parser we created a type. Is it a constant? May or may not want that. In fact, take that out. It's either going to be a kind, of which are up here, user defined, and I've already decided that I'll have a string ID for the user defined type. Otherwise, it's one of the known ones. String IDs are unique. They are not unique. If you have two modules, two structs with the same name, then they would get the same string ID, in which case they would resolve to the same type, which they would not be because there were two separate identifications. Which tells me string IDs are terrible. What do you reckon? I have not done type checking for a long time. I can see how to do it. I'm just trying to figure out the best to structure it. Maybe I should just start writing something and see how it goes. We need a unique ID. Each type needs a unique ID, so let's write that down. Each type needs a unique ID. sim tab. We're going to be typing that a lot, so I don't want it to be long. It's going to contain us. Entry. Entries. Okay, that's tell. And it's got to have a sim parent. Don't really see that. We'll cut that. Struct sim entry equals Stuart ID identifier and type. We need a level of interaction when we add structs, but we don't have structs, so there's no point worrying about that now. Type. So type is going to be what's in the parser.h, so this guy, so an unknown and a string ID. Got simplifying already. I've got to think this is going to. Okay, keep you there. It'll be like a new typing house scale. We'll keep you for now. Okay. And now we want symbol. You can't have a pointer. Should use pointer stability again. Annoying. We know allocators are the way forward. As and when I figure them out, how best to implement them in this environment. The simple is going to have that. It's going to have a function. It's a structure, isn't it? Cool. And then create. I think we decided to go new, didn't we? New table. Okay. This is dodgy because you're doing reallocations when you're not. This is not memory safe in the face of exceptions, but I haven't turned exceptions off, so let's just knew it and pretend I'm not looking. Don't worry about nulls. Allocations never fail. And certainly they never fail when you're doing a pushback. So if pushback throws an exception because it fails to allocate memory, we leak tab. I don't like doing it like that. Tempted to use unique pointers. But this is rough and ready code and we're not going to. Eventually we will replace it with an arena allocator again, which will mean getting rid of the stud vectors. Pain. Yes, it does mean getting rid of stud vectors, so maybe I in the end decide to harden this off. Harden off. I should really Google pointer stable vector container. What are you going to get? The alternative is I use a pool allocator on that, so I know I have to destruct them all. Which should probably get me halfway there. Efficient allocation, but group allocation, but still get destructors called without having to worry about them. I always wondered if you did an arena allocator, but put a pointer to the destructor just before the memory. Called a destructor on the memory. That might work. I've never tried it. I'll have a little play one day. Makes your memory allocation slightly bigger, but you're grouping them together, so you're not having. Oh, I know. Stop worrying about it, Paul. Right, we probably never need to look up a simple table. Putting this down here for a reason, but I can't because that's got to go in there. There you go, first problem. So the problem is that I don't want types, I don't want symbol table to be done on the parser because we're going to store a symbol table inside every single node. So when we walk it, we can just get out the symbol table. Symbol table. Inside every code, inside every node is going to be null. Because I'm not worried about the size of the AST node at the moment. But the end result is that you don't want type to be inside the parser. So guess what we're going to create? Another file. Do we go for a class? Yeah. Types. View. Eventually a symbol table and stuff will live in here. File creation day today. Should get an error there, yep. And we still haven't fixed up that. March the 1st, or the day I hit my computer, is the day I'm going to sort out some of these issues. What do you mean? We want to include you to not be there. We want you to be token kind to type kind. We need to be types. That's where you live. Now we should be building, except for something down here. Phoning goodness. No phoning goodness. Good. So while I'm messing with this, we're keeping it in main. All this will move to types. If I put it above the parser, then the parser knows about it because this is the only place we include the parsers. Go parser. And all is good. Simple tables, we will need to create an instance of here. Tabs. And then we're going to need a type check. Type check AST. What am I talking about now? That's going to be independent of the parser, so let's put you here. All the while I'm thinking, how can I mutate this code? I'm not writing the best code you possibly can. Nowhere near it. Because that way it leads to lack of productivity. I've forgotten something I was going to do somewhere. Type kind. No, I did move that. We are going to make operations check. Now, do nothing. Do nothing. Got a reference, it's got a pointer to you. All is good with the world. Got the parser. So what does the parser need to hold? It needs to hold a simple table pointer. Well, the parser, the ST. Parser does not do anything to do with this stuff. I might move its type, so I don't like that. Yeah, but let's move it. I wonder why it doesn't let me another one. consistently may flow out. Yep. Okay, I am being summoned for a little while. Quite sure why. We shall find out. Yep, right. I'm going to turn the mic off and oops, I'll leave it streaming. I'll only be a few minutes. And we return. My other half was booking some flights to New Zealand for part of a university course. And, going over to look at people's feet, believe it or not. And I shall be having children, and I will try not to break them in any sense of the word. Might get the surfing lessons when Mum's not around. So where were we? I probably wasn't speaking much actually. Yep, mic's back on. Woohoo! Right, so we've added a lot of files, we've added vectors to this. Our build time earlier was 766 milliseconds. I have got an obsession with build times, I'm really sorry. Let's have a look at it now. 633, that's probably within the noise. God, where was it? Rebuild project. Maybe he's got faster. We were pushing things into more files, so maybe that's it. Rebuild all in debug. I'm happy with that. Looks like the time's gone down a little bit. Excuse me. Watching someone text on a stream, that must be exciting. Almost as exciting to watch someone code on a stream. Someone who's totally lost his train of thought code on a stream. Where were we? Right, we've got a... let's think about this. Do we want to... Control Z, not Control X. Really? We want to... What is the point of that? Let's do you. Isn't that better? I'm not sure we can use simple tables, but they're generated from the type stuff. Travel insurance conversations. I'm glad I'm not in the room. I'm going to check she's not watching. Or I'll be in trouble. We went for peak, not peep, as the dictionary stuff. And cool. Things are going on. Excuse me. My throat is getting a lot better, and I'm going to one day go back and watch episode 1, or maybe the couple of us things I did at the beginning, and see what I sound like. Feel. It is fill tables. Create tables. Create tables. No, because this is going to be recursive, so we do need to awesome. Void tables syntax. But now we're well into AST. This is going to be a private function in the end, static function in the end, so is where the walking starts. And this is where I think a couple of things we need to do. First of all, our type object is not good enough. Where are you, type? And when we walk all this, it's going to, we're going to do stuff for the binary operations and unary operations separate, whereas if we have them all within the children's list, then we can, thinking, have a general routine, a more generalised routine. We'd have to go unary and binary. Guess what we're going to do next? We're actually going to go and do a bit of refactoring, which gives me a chance to think about these tables. So, refactor mode. The goal. Get rid of that. Let's delete it. Let's delete that. Let's build. Yay. Mouse control, because I don't know the Linux shortcut for that. No. Earthchild. Earthchild. Now we search for you. Oh, God damn it. Yeah. Earthchild. Right, let's go back to main and inside our function, let's do -1. Let's have a look at you. Leads forwarding excitement. Unary, so it's still printing, so that's good. We've got some binary stuff going on there, haven't we? +60, yeah. So, parser. This one's going to take a little bit more. I'll get rid of you. We're going to have to use the going to have to use the block have to use the AST build on some of these, I would imagine. Let's go find one. Earthchild. Sibling. We'll try this so quick, we can just do that. Ooh, wrong line. Look at what you're doing, not look at your keyboard. And then placing 2 lines with 3. Oh no! This is kind of where I wish I was using test now. Not the way button, I'm checking. You know what? I'm going to that I actually expect it to take longer. Let's have a check. What are we doing? 9, 10 o'clock. Oh, I'm pretty happy with that. Right, first goal. Some to-dos. Before we go any further, let's do that. We've got 12 warnings we need to fix. And I still need to put all the warnings up, so let's put that up. Turn up the compiler. So if you notice, we've got, well, the way I like to develop is a sort of continuous cycle on things. So, you know, some improvements, some progress forward, going back, cleaning up a few things, turning on compiler warnings, you know, gradually hardening and stuff, but always some steady progress. So create tables. What do we need to do? It's a two-part stage, two-part process. One, create the actual tables. Two, we still don't have a way of representing functions in our type, but for now, I'm not going to worry. And the other important thing is we don't have a root table. Sim star. What are we going to attach things to? See? Now we want auto module sim tab equals sim new table null pointer. Look at you, what are we doing? What have we got here? There are no entries. Cool. Keeping this nice and light. And then here we go, we're back to that. Exciting times. Switch. So we can look at the node. And we are going to look at its kind. What are we interested in? ST kind. Code block. Case. So we only need to create new load type. First of all, we've got a default because we're not going to be handling all the AST node types in this thing. We're interested currently in the code blocks. Whenever we hit a code block in create tables, we're going to create a new symbol table for it and give it the parent one and then recurse into it. No, I don't like defaults very much. So, let's create a new node. So, tab course new table parent is current. Cool. So these two are the only two that create new code blocks. Both of them have a very simple thing. Created a new table. 4. Auto. Statement. Should create a little macro or something for each. Thing. And then what have we got? We've got tables, tabs, a node. Awesome. So the standing outy one is function def, because we currently have its children as parameters. Oh, interesting. So we've got ED special case. Coolio. Now, what I want to do is do that again. This time with function code block. So walk the parameters, which will let us fill in the simple tables, and then we walk the rest. Cool. Interesting. How am I going to test all this stuff? Excuse me, so I get a bit hoarse. So we hit a new code block, and we do our stuff. So that could be from list statement or a while statement. We hit a module block, we do a similar thing because it just does this. That. Now if we do case, what other use cases are there? For loops, let vars. I'm not sure. Let's have a look. Parser. Look up. Do we have? What have we got in? Function def. Yeah, that's what we're after. Got parameter kind. That's what I wanted to make sure we had. Parameter. Then I think you've got identifiers and all that sort of thing. those are easy pickings. So we've got 4 loops. I don't. We've got 4 loops. Got while loops. We do not have 4 loops yet. Good. Bad. Good. I don't know. Look at that. Let vars and parameters in places where variables can be created. Variables, symbols are the things that need to go in there. Function definition. We'll also need to add a return type. No. Install the function signature, and then we need to fill in the my I's and A's. I'm not dyslexic, but I certainly seem like it sometimes. We need to fill in the signature, put that into the symbol table, the new old symbol table. Then we need to go through all the parameters, add them to the new symbol table for the function, which is what we're going to do there. And then finally we need to iterate over, finding any lets and things like that. So let's do a simple one. Case st simple. I don't actually know what I'm doing yet. Var definition. The let keyword. Do we definitely have a... Yes, because it would have been a syntax error not to do that. So entries, push back, in place back. I know, I don't worry. String identifier and type. No need to go into the children of that because, so the children would contain the expression to initialize it. You will not be doing any variable declarations in that. Awesome. Most of those you don't need to walk into, so I'm thinking I'm going to default this in the end. Okay, AST. Oops, going to 10 o'clock. Parameter. This is great for peeking, isn't it? Look. A string AT, and then you've got a type kind. Current entries, pushback, slash string ID, slash type dot worries me here is that I'm not doing the putting a default in there means the compiler won't be able to guide me and say, hey, when you add a new ASD card, come and add it here. But there's a huge number of them, and I'm happy to default that, I reckon. How did that work? I wonder if it even works. Free valid pointer. Invalid pointer. Operate, delete. Some tables. Be here calling a destructor there. Something's got my new table maybe? No. Tabs because of that. Copying my value when you shouldn't be. Cool. I've no evidence that that's actually working. But you know what? It's okay. Create tables. Next thing will be fuel. Types. Actually. Typer? What do you reckon? Typer sounds a bit of a weird word. Don't like type check, so I'm going to write type check down here. Could overload it. This feels a bit weird. I also want to write do type check. There's some type propagation we have to do. But that is part of the type check because you're propagating two types. You hit two that cannot be converted, which is going to be all types. Then bad things happen. Then we are in trouble, aren't we? No, we're not. But who knows? Type. Propagate and check. Ooh, this time we only need to root because we will already constructed our symbol tables and put them in. So we're not putting them in. C /sim table tab. Yes, do tidying up. Good to go. This time we would log any errors. Type. No, into types now. Root. pull this onto my laptop and progress while crashed in front of the TV. Or I just go read a magazine or book. Should read a book probably. So what we've done so far is we have broken up the code into many files early on, simply we thought. We've unified the path and the AST node, so we no longer got the binary and unary problems. I'm half tempted to put the code block for the function in the children, so this is always code, and then in here have a AST node for the parameters. But, we shall see, I might do that later. We have added the symbol tables, which are not good enough yet, and well, they are good enough. The type object is not yet good enough. And I think we're only storing the type kind, which doesn't seem right. So yeah, it must be falling through and automatically creating it because there's only one. Type symbol table entry. Yes, it is. Okay. I'm okay with that for now. And finally, we now walk the AST, creating the symbol tables that we need and filling them in. The one exception is we're not adding the function name to the checker because our type doesn't let us specify yet, because you could have an infinite number. We don't store the type signature, so we need to do that. Type signature easy. Let's see how it goes. They've got a lot of to-dos to do, boom boom, which I'm tempted to have a go at, and then all is good really. Yeah. I think that's a pretty good hour and a half, including one simple distraction, which I apologise for. I should have made a cup of tea while I was out there as well. Yeah, okay. Right. It's a taekwondo night tomorrow night, so either I'm going to be exhausted and falling asleep, or I'll be in the mood for doing some billet coding, so maybe I'll stream tomorrow. And that is it. Okay then, good night.